Hi good people, Titus here for another Unreal Engine tutorial, and in this video we'll look at creating a mirror and talk about setting up reflections using Lumen, SSR or screen space reflections, and ray tracing. Let's not waste any time and jump right into it. Alright, so we have the basic third-person template. We need to create a reflective surface, so let's press Control Spacebar. We'll create a new material, so let's right-click, select Material, and we'll just call this M_mirror. You can double-click to open that up. We're going to hold down 3, click on the graph, connect this to the base color, hold 1, click in the graph, connect this to the metallic, hold 1 again, click on the graph, and we're going to connect this to roughness. Now our roughness needs to be 0, our metallic needs to be true, so we're going to set that to 1, and then the color, we can use a lighter color, maybe like a white. And then this gives us a mirror-like material. So we'll go ahead and save this. And now we just need to apply this to something, so we can just drag it onto this. And then looks like we have our reflections working already. So we can add an object in here, like the player, and you'll notice the reflection doesn't quite look accurate. There's something weird going on. And we'll kind of discuss this in a little bit, but let's go ahead and talk about what reflective settings we have. So you have 2 ways to adjust reflectivity in Unreal. You can do it on a project level. So under project settings, scroll down for rendering, and then we don't need to worry about mobile or materials or culling or anything with textures or color. Pretty much here. Here's your meat and potatoes. This is your global illumination, your reflections, lumen, shadows, and your hardware and software ray tracing. So this is going to be the bulk of the work you do. If you don't want to adjust it at a project level where it applies to all your levels, you can adjust it on a per level and per area instance using a post-process volume. So if I click the add button, search for post-process, I can drag that out here. It creates this little cube, and then I can scale the cube, and anything inside the cube I can basically apply these reflectivity settings, but you can also do things like global illumination, shadows, as well as sort of camera effects and all sorts of other things. If you want the post-process to affect your entire level, you can select it and then scroll down near the bottom. You're looking for post-process volume settings. You need to check infinite extent unbound. And that'll make it so that the cube basically just being in the level will apply the post-process settings to everywhere in that level. And then going back up, we're not going to be messing with film. We have our global illumination and our reflections. So right now you can see we are reflecting, and we're also getting shadows and lighting using Lumen. And we're getting about 60 FPS. So for our global illumination, we'll kind of mess with that in a second. Let's just talk about the reflections that we have. So we have screen space, ray traced, and Lumen. Screen spaced is basically the way it works is, let's go ahead and select it here. It takes an image from your camera target. So basically whatever in this case, it's the viewport, but when you're playing the game, it's your camera actor. Whatever the camera's capturing, it'll take that image, it'll sample all the pixels in it, and then it'll approximate a reflection using those pixels. So there's inherent limitation with that. If I position my camera in a way where I can see this back wall on the left, you can see in the reflection, it sees the back wall. As I move my camera away from the back wall and more towards the reflection, because the pixel data is lost from the viewport's camera actor, it can't reflect it because it's not being rendered over here. And this is the limitation with screen space reflections. They can basically only reflect what the camera can see. Same thing with the player. You see the player looks a little bit hazy and fuzzy. And it's because I can only see this side of the player. I can't see the back side. So that pixel data is not available for the screen space to reflect. So that's why it looks a little bit hazy. When you select an actual reflection, you can adjust the individual settings for that reflection type. So in this case, we're using screen space, so you can adjust intensity, quality, and the roughness value at which it begins to start reflecting. So even if I bump up the quality, it's not really going to matter because it can't, you know, get that pixel data. But if I shift my camera in such a way where the reflection and the image don't require the backside of it, you can see it becomes more accurate, and that's because I don't need the pixels from the back. So depending on the angle of the reflection that you're doing, screen space reflections can definitely work. They are extremely performant. So if you're looking to save space, or if you're developing on like a mobile platform, or if your platform doesn't support ray tracing to begin with, either hardware or software, then you're unfortunately going to probably be stuck with screen space reflections. So it's good to know their limitations, how to work, so you can place your reflections strategically to where they will work. And then you can also overlap them. So other tricks that we typically do for like older games, like if we turn reflections off completely, you can overlap SSR with reflection capturing devices, which is what we used to do in the older versions of Unreal. So if we go to the add menu, you search for reflection, we have sphere reflection capture, box reflection capture, and planar reflections. They're basically they all work kind of similar, with the exception of planar reflections. But like sphere and box, basically what it does is it's using an actor in the scene. We'll take sphere capture as an example. The sphere capture will take 6 rendered image. Gets one from the front, the back, the left and the right, and the up and the down. And it creates a cube map. And if you watch my older videos, you can look up like sky sphere cube maps where we create those. And basically, once you have those 6 images, you can kind of create, normally use it for sky maps, but you can create a reflection surface and cast that data onto a particular material or object. So if I place this here, and then let's move this back a bit, you'll notice we have a working reflection. It's a little pixelated, and it looks a little bit bloated, and that's because it's using a texture to do the reflection. So if I go to my project settings, you can see my resolution of my reflection is only 128. So if I do something like obscene, like 1024, you'll see the reflection becomes a lot more accurate and a lot more crisp. There is an issue with this type of capture though, is it doesn't capture dynamic objects. So you can see the player and the cube are not being reflected. If I select the cube and I set it to be a static object, and then I go to build and I rebuild reflections, you'll notice the cube sets back up. So it can only capture basically static. It takes basically a rendered image of your scene and it creates that cube map, and then it uses that data to feed out the reflection. So extremely performant, but limited in that respect. It also matters where you place your reflection capture device. So if I place this in front, and then I go back and I build the reflection data, you'll notice the cube is gone. So wherever you're doing your reflective surface, make sure you place your sphere or your box or your planar reflection capture component appropriately to be able to capture those reflections. But you can overlap these two. So we can use this in conjunction with something like screen space. And then you can kind of make that work if you overlap them, but it's very difficult and it's kind of a pain. So I usually wouldn't recommend doing that. But that's basically screen space reflections and capture targets. I'll also give you another trick at the end of the video that's very similar to this, but still slightly different. But let's go ahead and move into ray traced. So let's delete that. We'll go back to our post-process volume and we'll set our reflection to use ray tracing. Now right off the bat, you'll notice it looks awful. This does not look accurate, and there's definitely something else going on here. Mainly this is because of our project settings. We haven't enabled ray tracing. So under project settings, there's support for hardware ray tracing. You'll want to check that. That's going to require caching, so choose yes to that, and it's going to require a restart. So go ahead and save your project, restart, and then we'll get back to it. All right, and we're back. Okay, so you can see we have a very accurate reflection using software and hardware-based ray tracing. Looks very good, it's very accurate, and there's usually no issues that you're going to find with this. So the way ray tracing works is it basically takes the camera actor in the world, and it'll cast a ray from its viewport onto an object using vector math. It'll do a computation and figure out a bounce, and depending on your project settings, you can define, 1 bounce, 2 bounce, 3 bounces, and it'll basically keep that ray going and hitting different targets, and it'll basically sample and apply appropriate lighting, shadows, and reflectivity based on the materials it's sampling. This is very expensive because it's very computational, but it is also extremely accurate. So you're going to get the best looking reflections using ray tracing, whether they're hardware or software based. Now, a lot of people, they'll want to, they have maybe a prototype or a game where they have a room with a reflection or a mirror and they want to use ray tracing, but they can't because it's too expensive. And a lot of times I notice with these examples is what they're doing is they're typically using ray tracing for the entire global illumination and the reflections. Unreal does give you the ability to split those. So like as an example, I can, come down to my global illumination and I can set this to be screen spaced and then use my reflections to be ray traced. And you can see I'm getting 100 frames with a very accurate reflection here. So that is an option. You also don't have to reflect the entire world. You can use these post-process volumes and scale them and only do it on a particular, part of your map. So you'll still be able to get the frames, like if you're targeting 90 frames per second for your project, and you have some reflectivity just that for your scene that you need, you could still use, ray traced reflections and then just use screen spaced or baked lighting to kind of save the space, save your FPS budget there. And another thing you can do too with ray tracing is you'll notice the character model is a little bit dark. I think it looks okay, but under the ray tracing settings, right now we are only using 1 bounce. If I set this to 2, look at the character and the reflection, you see it lights right up. It's basically the ray bouncing and getting more data. So the increased number of bounces as well as your samples per pixel, you can up the fidelity of the reflection that you're using for some of these captures, and they look pretty good. So that's pretty much ray tracing. I like ray tracing a lot. I wouldn't shy away from it. It's pretty good. The other reflection option is Lumen. So Lumen is basically the best of both worlds. It combines your SSR, your screen space reflections, with software and hardware ray tracing. So basically it's using ray tracing where it matters, and then it's using screen space reflections everywhere else, and it's kind of doing that optimization. Now the one thing with Lumen reflections is it requires Lumen lighting for it to work. And you can see it's obviously not as good as the software or hardware-based ray tracing, but it does give you, an okay reflection there. You can also go into your project settings, and there's some tweaks you can make to the rendering tab. So we go back to rendering. You could tell Lumen to use hardware-based ray tracing, and that might help a little bit with some of your reflections. Another setting you can do is the default is to cache. It's a little bit more expensive, but you can use hit lighting. And that'll sometimes help out with some of those reflections. Usually if I'm using Lumen for reflections, I will actually go into the reflections and I like to set the quality down to get kind of a blurred mirror effect. And I think that looks a little bit better. And then the reflection bounces I think only works with hit tracing, but I don't know if that's bugged in 5.3, but it doesn't really seem to work. I might be missing a setting on that one, but if your reflections are a little bit dark, that might be why you're only getting the 1 bounce. But yeah, that's pretty much Lumen, but you can see Lumen, because it requires, Lumen reflections requires the global illumination to be Lumen, at least for my 5.3 it seems to. It's a little bit more taxing on your FPS budget. If they can somehow split that to where just use Lumen reflections separately, and you can use maybe screen space for the global illumination. You can get comparable performance to the hardware and software-based ray tracing. So, but yeah, basically Lumen, I guess the best way to think of it is it's kind of similar to NVIDIA's deep learning super sampling or AMD's Fidelity super resolution, where they're rasterizing or they're rendering an accurate image, like for image 1, but for image 2, they're kind of basically sampling the data from image 1 and kind of faking that second image. It's kind of what Lumen's doing, is it's using some ray tracing, but then it's basically using a lot of screen space and other optimization techniques to kind of fake some of that fidelity for the rest of the image to target a specific frame rate. Now for reflections, I don't particularly like Lumen too much because you see it's not as good. But for lighting, it's amazing. So yeah, I would definitely use it for your global illumination. So it's definitely not something you should shy away from. Now, some troubleshooting tips I'll give you. Let's bump the quality back up to 1. If your reflections are still not looking right and you're following this tutorial, definitely check your scalability settings. So under settings, top right, and then engine scalability settings, which I have it up here. You might be low, or you have some other, issue where that might be impacting your image. So check there. Obviously, the higher quality, the more expensive it's going to be. But that might be why you're not reflecting. Like if you're in low, I'm getting 120, but I'm not reflecting anything. If I set it to medium, I'm getting some reflections. And then if I go high or epic, I'm kind of getting there with my reflections there. So that might be one area to look at. The other one would be your material. So for this tutorial, we created an opaque material, but maybe you're not dealing with an opaque. Maybe you're dealing with translucent materials. And then your lighting mode isn't volumetric. You're using like surface translucency or surface forward shading, any of those. If you're in that, then you may notice that nothing you do is kind of getting the reflections to work for, let me go into here, and let's set the reflection to say ray traced. So maybe you're getting this sort of issue where it's like, what the heck, it's not working. Why doesn't mine look like his? It's because a lot of the settings we were targeting was dealing with an opaque material. So translucency typically will have its own section, so you'll want to make sure to check that and set that to the appropriate setting so your reflections will actually show up. But yeah, if you want my best reflection settings that I like to use is I'll use my global illumination to screen space, and then I'll set my reflection using ray traced. And I think that looks pretty good. And I can usually hit my 90 FPS target that I'm usually going for. And I think it's pretty accurate. If you need a blurred mirror, you can of course do that in the post process, or you can also use Lumen for that. The most efficient mirror that I found, it's an older technique, but it's one we used for a while. What you can do is use a render texture target with a capture camera in the scene. I did a tutorial using like security cameras, and it was outputting the feed of the security camera to like a wall panel. It's basically that. You create a mirror static mesh, and then you place your capture camera like inside the mirror, pointing out. And then you output the feed from that camera to a render texture target. And then you can set the texture resolution in that actual texture component, and then you can create a material off of it. Then you just apply that material to the mirror's static mesh, and effectively what it's doing is it's not really a reflection, it's just a camera feed, but the player is not really going to know any better. The thing that stands out the most with it though is the angle of reflection will be off. So if the player comes at a different elevation, like lower or higher than when the camera is, the positioning of the reflections of the objects around the player will look a little bit off. So what you'll want to maybe do is you can target the player's Z height, and then you can, anytime the Z height changes on the player, you can update the capture camera's Z height, and then that'll kind of fix that. And that was a trick that we did way back in the day for you know, screen mirrors and stuff like that, just to get around it. So that's very, it's very accurate for mirrors. If you needed something like that, that'll work. But if you don't mind giving, you know, just adjusting your mirror settings, you can also make it work with like ray tracing or Lumen, kind of either way. All right, everyone, we'll cut the video here. I hope you found some informative value that you can take into your own projects. But as always, thanks for watching. Consider subscribing, and see you on the next one.